Okay, so hello, yep, I will tell you the solution of this question and I will explain this question in a particular way. So the first thing that the we have to find the total acceleration. So let me open the pen. So we have to find the total acceleration of the point. So a point is moving in a circle and we have to find the total acceleration. Now, whenever in the question you will get something called as total acceleration, the one thing which must come in your mind is that there must be two or more kind of acceleration, so that they are asking about total acceleration. Else the acceleration is only one. So total acceleration should not be there. So here they are asking about total acceleration. So how? Because acceleration is only one property. So how there can be two types of acceleration? So that particular part is given here, that is it's a circle. Okay, so it is a circle. So now when I open the pen, let me tell you that this is a circle. Okay, so one acceleration is that is letting this point move, letting the point move. And you can see here the velocity is increasing. So the velocity is, if velocity is increasing, there must be some acceleration. So we have to find that acceleration, and that acceleration is tangential acceleration. That is, we have to find tangential acceleration. And the second acceleration that let this point move in a circle. So this is a point, and this particular acceleration that is called as the centripetal acceleration, that is towards the center. So we have two kinds of acceleration, that is centripetal, and the first is a tangential and the second is a centripetal. And when we will find the resultant of both the acceleration, then we will get that there is something called as the total acceleration. Okay, so now let me move to the answer first. So here what you can say, or what I can say, is that we have to find firstly the tangential acceleration. So what is tangential acceleration? So tangential acceleration is like the simple acceleration. So the formula of tangential acceleration is a t is equal to, that is acceleration tangential is equal to dv by dt. So since it is a circular motion, we have to consider uh, many things. Okay, so this is like something, wait, I will tell you. So here the value of v is given to us. So value of v is given to us, so we will just put the v there, and in the place of this v I am just writing that is 80. Okay, so this is 80. Okay, now you must have done this kind of differentiation. So what is the formula of differentiation of this particular kind of things? I don't remember the formula, but I remember one thing, that the power of this t is subtracted by 1, and the power of this t comes here. Okay, so it comes at the top. So the power of the t is 1, so it is like 1 into a, that is constant, and into t. So this is t, so t to the power 1 minus 1, that is 0, so that is 1. So this will come out to be a. So we have got that our tangential acceleration is equal to the acceleration which is given there. Okay, so this is the kind of acceleration which we need to find. Now we have found that what is our tangential acceleration. Now the second thing that we need to find is the centripetal acceleration. So the acceleration which binds the point in the center. So that's AC. That's not air conditioner. So this is a centripetal acceleration. So this centripetal acceleration is equal to v square by r. Okay, so this is v square by r. So now when we will find this v square by r, we will use the simple formula, that is v is equal to 80. So we will put the thing, that is v is equal to 80 there. So that will give us the centripetal acceleration. So we will put the v is equal to 80, because this is a simple formula, there is no change, no that kind of thing. So we will simply put the formula. So at the place of v square, we will put a square t square, because v is equal to 80, a square t square. So I have put a square t square. So we have got our centripetal acceleration too. So this is our centripetal acceleration. Now what we have to find, just we have to find one thing. So let me just erase this particular part. So this is erased now. Okay, so what we have to find, we have to find something. Let me show you. Okay, so the total acceleration, that is a, will be equal to the resultant of 80 plus at square plus the resultant of sorry not the resultant plus the centripetal acceleration, that is a square t square upon r. So this is our centripetal acceleration, that is r's okay to the whole square. Okay, so if we just do the whole square of it, so we will get like this. So let me write it well. So this is a is equal to under the root of a square plus, that was a square, so we will write a to the power 4 t to the power 4, that is a square t square ka whole square. So a to the power 4 t to the power 4 divided by r square. So this is our formula which we will put and we will get the answer. Okay, so this is that. Now when I am going to solve this, so I am going to solve it in a whiteboard. So I am just finding the whiteboard. Where is it? So this is whiteboard. Okay, so this is my whiteboard. Okay, so in whiteboard, let me take a next page. So this is my next page. Okay, so this is my page number 4. So just I will write it there. The first thing is that we have got the formula which we where we will put something, that is a so let me write with this pen. Okay, so we have a is equal to under root of uh, a t ka square plus ac ka square. So this is the formula of resultant. Now this is only the formula of resultant. So this is a, that is equal to under root of a square plus a square t square ka whole square. So that whole square we will write it like this. Wait, let me write it, that is a to the power 4. We have to write it like a to the power 4 and t to the power 4. So a to the power 4 t to the power 4 upon r square. Okay, so this is like this, and we have to put the values. Now what things we don't know? So things we don't know are the value of t and the value of r. So we have to substitute it by some other thing so that we can find the value easily. Okay, so one thing that is given, that it is traveling to the 1/10, means 1/10 of the circle. So let's moving to the next page. So they are traveling 1/10 of the circle. So the distance they traveled, or the theta they traveled, that is equal to 1 by 10 of the total angle, 1 by 10 into 2 pi, 1 by 10 of 2 pi, so that is 2 pi by 10. So we have got our theta is equal to 2 by 10, 2 pi by 10. So this is our theta is equal to 2 pi upon 10. So this is our theta, and this is equal to pi by 5. Pi by 5 is our theta. Okay, now we have got something called as r2. So we have r, that is we have to find r. So we have got the value of theta, that is pi by 5. Now we have to find the r, that is r. So we know that s is equal to, that is the distance. So we know that the distance is equal to r theta. D is equal to r theta, we know this. So we know that d is equal to r theta. Then the second thing which we have to do is to substitute this r or substitute this d to get us a simple formula for this whole process. So now what we can do, that we can write something in this place of d. So what is d? D is the distance. So distance is equal to integration of v dt, that is integration of v dt is equal to the distance. Now that is equal to r theta. Okay, so integration of v dt, so we can find that here v is equal to at. So in place of v we will write at. So integration of at dt is equal to r theta. Okay, so integration of at dt is equal to r theta. Since a is a constant, a has the value 0.5, so we have so we will put a bahar, and then we get t dt, and the integration of t is t square by 2. So integration of t is t square by 2. So just I will put t square by 2 there. So that would be simple. That will save my one step. So t square by 2. So at square by 2 is equal to r theta. So now in place of so now I will move this theta. So now I will put the value of this theta. So the value of this theta is this is the value of the theta. So value of the theta is pi by 5. Okay. Now when we will move this pi by 5 at that particular side, then we will get that something, there is a value of r. Okay, so we will substitute that value of r there. So this r is equal to, so there it was pi by 5, so here it will 5 by pi. Pi by 5, and there yeah, here it will be 5 by pi is equal to r square. So 580 square by 2 pi is equal to r, that is equal to r. So now we will put that particular thing in this particular part. So there we go. So now what we have to find, that we have to find a square plus t to the power 4. So we will put the value of r which we find there. So we will put that particular value here. So this will look like something this. Let me show you. Okay, wait. Yeah. So it will look like a is equal to under root of a square, sorry, this is a total na, a capital T, a square plus a to the power 4 t to the power 4 t to the power 4 upon, that is r square. So what we have find the value of r, the value of r we have found is 5. So 5, so we have found 5, and then wait, let me see, that is 580 square upon 2 pi, 580 square upon 2 pi, and that 2 in square. Okay, so we will just simplify it. So we will just cancel the square from here. How can we cancel the square? We will just multiply everything with the square. Okay, so that is 5 ka square is 25. So we will simplify it. It's 5 ka square 25. A ka square is a square. T square ka square is t to the power 4 upon, what is that in upon? We have in upon that we have 5 a square. Wait, this is so much long. Okay, so we have like this. So 5 a square t to the power 4 upon what we have in upon we have what? So in upon we have 25 a square t upon 4 pi square. Okay, so now we will cancel something, that is t to the power 4 upon t to the power 4. This 2 and this 4 will change to 2. So now after simplifying it, after just simplifying it, we will get at, that is total acceleration, is under root of a square plus, so this 4 pi square will come up, and 25 will stay down. This a is cancelled because of that a to the power 4. So that will come out to be 4 a square pi square upon 25. 4 a square pi square upon 25. 4 a square pi square upon 25. Okay, so now we have to just simplify it more. So for simplifying, we can do what? We can just commonize this denominator. Okay, so the denominator is 25. We take LCM of the denominator. So LCM of the denominator is 25. So it is 25 a square, and this is whole. So and this is 25 here in the between. It is 25. Okay, so now what is there? This a square is common, so we will just write a square as common. So this a t is equal to under root of a square is common, and what we are left, and in the bottom there is 25 common, and what we are left with, we are left with a square is common, 25 plus 4 pi square. So this is 25 plus 4 pi square. Okay, so it's 4 pi square, pi is 3.14. So we will just assume it to the near value. So for a near value, what we can do, we can just assume it like pi. So pi is equal to 3. Let me take pi is equal to 3. So pi is equal to 3. So pi square is equal to 9. So that is 25 plus 36. So in the place of this 4 pi square, I am writing 36. So this is 36 I am writing. So this is 36. Okay, now this a will come out, so at that will equal to a by, so 25 का root is 5, under root of 25 plus 36, so that will come out to be 61. So 61 is near to the root of 64, so 64 ka root, so 61 and 64 are real, they are so close. So what we can do, we can just consider is at 64 only. So after considering it, what we can get is a by 5. So this is 64, under root of 64 is equal to 8, so in place of this 61 I am writing 8. So what we get, this 8a upon 5. So the value of a is 0.5, just putting the value of a there. So this value of a is 0.5, 0.5. So this is 1 upon 10, so that is 8 upon 10. So 80, the total acceleration is equal to 8 upon 10, so that is equal to 0.8.